We'll start with a discussion of the second prelim paper. The first multiple choice question is work has three direction nor magnitude, neither magnitude nor direction, or it is only magnitude and no direction. So C is the correct answer. The reason being work is a scalar quantity. The second one is Prutha raises the bulky book against gravity, lifting it vertically. The work done by the book is negative. Okay, so they are asking work done by the book, not by Prutha. So that is negative because gravity always acts down. So that is the force of gravity, while the acceleration, sorry, the displacement of the book is upward. Then during free fall, the total energy is 3/4 the height is how much? Okay, so they are asking for the total energy. So what will be the answer over here? This is the gravitational energy at the top. So this is ground and this is the topmost position at H. So U is equal to mgh, and in this case kinetic energy is 0. Therefore total energy is equal to mgh. Now what happens is at any given point the total energy will remain constant. Okay, anywhere total energy will remains constant, whereas kinetic energy increases and potential energy decreases as the body goes down. Then to the next one, which of the following radioisotope is used to kill the cancer of malignant tumor? So this is cobalt-60. So this is the use, medicinal use. Okay, right. Then ratio of velocity of light. Now they are asking for vacuum. Vacuum, it is 1:1. Okay, vacuum is 1:1. Now, in the question number 6, what is happening over here is that they are saying the light passes through 4 transparent mediums, okay, and the emergent ray and the incident ray are parallel to each other. So this and this are parallel to each other. Okay, so what is the relationship they're asking? So first of all, if I draw a normal over here, I can see that the normal is the ray of light is bending towards the normal. So what does this tell me? That mu2 is greater than mu1. Okay, if it is going in a denser medium, it will bend toward the normal. In this as well, you can see that the light is bending. So therefore, this is greater. Now, the fact that the light is going parallel over here, that means they two are equal. Okay, and that the same thing happens in a glass slab. This is air, this is also air. So when a ray of light travels, it goes parallel. Here it bends. Okay, so there is a lateral displacement. And here also there is a lateral displacement. So therefore, the option is equal to D. Mu1 and mu4 are equal, and they both are less than mu3 and mu2. Yeah.
So I didn't understand.
Sorry, this, I think it is.
So I understood the equal, the 1 and 4 I understood. I didn't get the 2 and 3.
Okay, so one thing is there, if this is medium 1 and medium 2, this is a ray of light. If the ray of light bend toward the normal, means refractive index of second is greater than 1, because this will be denser, this will be rarer. So I am saying that, look, the dotted line that I have drawn here, so this is the direction of the ray, and it is clearly seen that when the ray of light is going in medium 2, it is bending toward the normal.
Okay, I got it.
Yeah. So it is denser, this is rarer. Okay?
Yeah, I got it.
Fine. Question number 7. A sound wave is reflected from a brick wall. Compared with the incident wave, the reflected wave has same speed. Remember, when a ray of light or sound is coming back in the same medium after reflection, it is the same medium. So the speed will be same. Okay? Velocity is not same because earlier it is directed this way and now it is directed that way. So the direction has changed. So greater amplitude means it will be heard louder. That is also not true. And the frequency is also not changing. So there is no change in wavelength. Okay. This one also was very easy. So this is 100 hertz. So there are one loop over here. There are 2 loops. So that will be 200, 300, 400, 500 and 600. So this is the answer. Bottommost wave.
So,
okay. Yeah.
Sir, can you explain the 7th one once again, please?
Okay. I'm recording this, so it will be, you can watch it again. I'm saying that when the sound wave hits the wall and returns back, it will have the same speed. Okay, if it is traveling with 340 meter per second towards the wall, then after reflection also it will travel with 340 meter per second. That's what I'm saying.
Okay, sir. Okay.
Yeah. Now, question number 9. By maintaining the same potential difference, the conductor resistance is doubled its initial value. As a result, the heating effect will be what? So, heating effect is equal to I square RT. So, if the resistance is doubled, so I will take 2R over here, and they are keeping the same potential difference. So, V is equal to IR. So, therefore, if I have 2R, then it has to be I by 2 for V to remain same, because that is going to get cancelled. So, I squared will be I square upon 4. So, this will be half of I square RT. So, this will be half of the initial value. Okay. Anyone has not understood? Okay. Let's move to the next question number 10. So, this is X, this is Y. So, over here, what I'm doing, I'll take a point. So, say probably I'll take this. So, this is 8, 2, and I'll take this point 0, 0. So, the slope is going to give me resistance. This is I, this is V. So, resistance is equal to delta V upon delta I. So, that is 1 upon the slope value. So, that is 2 minus 0 upon 8 minus 0. So, this will be 4 ohms. Okay. And which is the other one? I can take this one, which is 6, 3. Okay. So, here the slope will be 1 upon 3 minus 0, 6 minus 0. So, the answer will be 2. So, that means the X value is 2 ohms and Y value is 4 ohms. Okay. Was there an error in this one?
No, the answer is
7. No? There is 10 and 2, I think. Yeah, this 2 and 10 are on this. So therefore, this is 5. Yeah, 8 was not exactly at 2. So this is 5 ohm. So therefore, 5 plus 2, that is 10 ohm. Okay.
7.
Again, sorry, 7 ohm. This line also is like kind of curved. So the image is not very clear.
So,
yeah.
So, but why did you add it?
Because they are in series, they said.
Oh, yeah. Okay.
Yeah, they are in series. Okay, now here we have the left hand rule. This is positive, this is negative. Current is flowing like this. Okay, this was a trick one because they had asked for ST. Everyone will think about this and this side. Fine. So if you take your left hand, this is the magnetic field ka direction. So that is on your screen, left to right. Okay. And I'm talking about RS. And this is the direction of current, I. So this is on your screen going down. So this is top, this is down. So I'll just rewrite again. The magnetic field is going left to right. Current is going top to down. So your middle finger has to be pointed downward. So I hope you all will agree that your thumb is coming out of the screen. Okay, so here there is out of the page. Followed. Now, F is equal to B I L sine theta, where theta is the angle between a magnetic field and current. So when you talk about ST, the magnetic field is in this direction and the current is in the opposite direction. So the angle theta is 180 degrees. So sine of 180 is 0. And therefore, there is no force. So B is the answer. Okay. Any questions, anyone? Okay. Then which of the following substance contract on melting? The answer is ice. So because it says B and C, but you know that ice contracts. So therefore answer is A. Going ahead. Now, this was a question which will take longer time to solve, but there were other multiple choice questions which were shorter. So it balances in a way. But again, this question, it's too much to do for 1 mark. Okay, a thermal energy is added at a constant rate. That means the power is constant. Okay, and this is in a solid state. So this is a solid when time is 0. The graph shows the variation of time with temperature. Which of the following statement is correct? The specific latent heat of fusion, so that they are talking about this area, is greater than the specific latent heat of vaporization. So this is the specific latent heat of vaporization. So they are saying that this is more than this. So if I call this A and call this B, so according to here, A is greater than B. Now we know that that's not true because this is shorter. So the time taken is less compared to the time taken over here. So therefore B is greater. So this is false. Okay, they're asking which statement is correct. Now the second one, the specific heat capacity of the solid is less than the specific heat capacity of the liquid. So they are saying that solid specific heat capacity and liquid specific heat capacity. So the just a minute. The specific heat capacity of solid is less than specific heat capacity of liquid. So what do you think? Is this true or false? Anyone?
Sir, it's true.
This is true. Okay, now there is a general rule that, like, even for ice, it is 2100, and for water, it is 4200. So water, which is liquid, has a higher specific heat capacity. Now, how can you say that using this particular graph? Now, again, there is an assumption which I'm making because nothing is mentioned about that. So what is this temperature? We don't know. So if you assume this temperature to be T by 2, because this temperature is T over here. So the time taken for this, and if you take the time taken for this rise, so over here, this time 2 is greater than time 1. So if it is taking more time for liquid to rise to the same temperature compared to solid, liquid will have a higher specific heat capacity. So therefore, 2 is correct and 1 is false. Okay, any doubts, anyone? Fine. Moving ahead, here the question was 180-degree deviation. So you have studied this, and these are standard diagrams in the textbook. This is 45, 45, 90 prism. So this is the answer because the ray of light is going there and it is coming out 180 degree. Only one answer is correct in a multiple choice. So D is correct. If you know this is 90 degree, you know that this is going to be 60, this is 30, so it's going to go like this. And this deviation is definitely not 180. And in this case also, if it is bending here and further bending out, so this direction it is going, the normal. So this deviation is also not 180 degree. Okay, so D is correct option. So remember, many students must have got confused with this, but at least these diagrams were known to you. Okay, and you know this is 180, that is the end of story. You select it and go ahead.
And I got that right.
Very good. A small air bubble rising up a fish tank appears silvery. So you have studied consequences of refraction, consequences of TIR. So this is TIR. And here they are saying it is happening because of dispersion. So the assertion is true, but the reason is false for this. Okay, moving ahead. Because of dispersion, remember, we see rainbows. Okay, now these are two parallel rays of light. So this is yellow, this is blue. So when I draw a normal over here, okay, and this is VIBGYOR. Deviation will be more for violet. So that means blue will deviate more than yellow. So this is the direction in which they are going. Both of them are parallel. But you have to distinctly draw the deviation of blue more than that of yellow. Okay, so means the teacher should understand that you have drawn it that way. I don't have a scale now, but one should, with your eyes, naked eye, it should be very clear that this one is bending more. Okay, no one has to take a measurement of the angle to show that. Okay.
Sir, if we don't know the angle of deviation, we got a
Yes,
zero.
sir. I got 0.
Same, sir.
So you had not shown this.
Yeah, we have to show that.
Yeah.
No, I don't agree with that. Even if you show it, what will you show? You will write here delta 2 and write here delta 1, and you write delta 1 is less than delta 2. But if you
So he wrote on my paper angle of deviations not mentioned. That's why.
Yes,
Yeah,
I'm not minding
how will you show the value? Okay, even if they expect, this is what you can do. But they are saying draw the refracted ray. Okay, wait. The question has
sir.
asked you. Yeah.
And mark
Then
it
it
out
is.
as written.
Then it is expected. Yeah. So if this is there, so but then draw the refracted ray should be 1 mark. This should be 1 mark, and this should be 1 mark because
Yes,
this is
I
3
got
marks.
1 mark.
Yeah, yeah. Then that's fine. Yeah, I didn't read that. So yes, if it is mentioned, then of course it is there. Fine. Now why explain? Because you can say that refractive index of blue is greater than refractive index of yellow. So blue will be deviating more. Okay. Then remote controls are used for operating TVs. What type of radiation they emit? So infrared radiations. What is the wavelength range of radiation? So that you need to learn and write. Remember, IR, UV, you should know because that's in the portion. For visible, this is 400 nanometer to 800 nanometer, or 4,000 angstrom to 8,000 angstrom. Fine. Now, this is a fishing rod. So here is your fulcrum, this is your effort, and this is your load. They are asking for the names. So that is what we have given. What is the mechanical advantage? Mechanical advantage is length of effort arm upon load arm. So effort arm is 30 and load arm is this whole thing. So that is 100. So 0.3 is the answer. Okay, remember this is class 3 lever. So MA is less than 1. Okay, from the equations given below, identify the nuclear reaction. So this is the nuclear fission reaction, and you have to define this. So you can refer to the book. It's defined over there. Okay, so like a heavy nucleus, and there is a neutron which will split this into two, and excess amount of energy will be given out along with 3 other neutrons. So that you can write. Then some radioactive nuclei decay to give a new nuclei. Yeah, so how many decay involve beta emission? So you can see that 90, so this is alpha, 90 increasing to 91, so that is beta, 91 increasing to 92, that is again a beta, 92 becoming a 90, that is alpha, and 90 becoming a 98 is also an alpha. So how many decays? So 2 decays. Okay. This question, so here from A to B, 24% of gravitational energy is transferred to the kinetic energy. Okay, so this is A and this is B. Now at point A, so B has potential energy of mg20. A has potential energy of mg50. Okay, so the change in potential energy is equal to mg50 minus mg20. So that is equal to mg30. And kinetic energy is 24% of change in potential. So that is 24 to 100. And this is equal to 65 into 10 into 30. So I'm going to cancel these two zeros. And half into 65 into V squared is 24 into 65 into 3. So this is going to get cancelled. And V squared is 12 into 2 into 2 into 3. So this also becomes a 12. So V is 12 meter per second. Yeah. So that is the velocity. Okay. Now diagrammatically illustrate how would you connect K. Okay. So this is a Ohm's law circuit. So instead of directly asking for Ohm's law, they have asked all this. Okay. They have said that the potential difference and the current relation, and you're keeping the physical condition and temperature of the conductor constant. So that's like a statement of Ohm's law. So you have a resistor, you have an ammeter, you have a battery, you have a key, and you have a rheostat. So you have a voltmeter over here. So this is positive, negative, positive, negative, positive, negative, and then you draw arrows everywhere. Okay, so that's the diagram. Now the seventh one. So this is a graph generally 12th graders draw, but you are not drawing the graph, you're just reading information from the graph. So I'm taking a point. So this is going to give me V and this is going to give me U. And they are asking for focal length. So 1 upon F is 1 upon V minus 1 upon U. So this is 20 minus 20. So that will be 1 by 20 plus 1 by 20. That is 1 by 10. So F is equal to 10 centimeter. Okay, no other point was clear enough that will give you the answer because you don't know what is this, what is that. Okay, moving ahead. Question number 3. What is meant by echo? So here there will be keywords that the sound is getting reflected. The original sound has ceased to exist. Okay, those pointers are important. If the natural frequency of air column in the pipe fixed at one end of length 17 centimeters, 500 hertz. Okay, then what will be for 250 hertz? So you need to remember one logic that this is the length of the air column and frequency depends on the length of the air column. And we have discussed earlier that for a higher frequency, the air column is shorter. So if the frequency is reducing, that means the air column will increase. So the length from 17 will become 34 centimeter. Another thing to remember is, such questions are not expected in the board exam, but frequency into length is constant. Okay, so therefore 17 into 500 is equal to length into 250. So that's how you got the answer. State any two factors on which magnitude of the force on a current carrying conductor placed in a magnetic field depends. So we have that force is equal to BIL sine theta. So it depends on the strength of the magnetic field. It depends on the strength of the current. It depends upon the size of the conductor in the magnetic field, and also the angle between force and angle between magnetic field and current. Okay. In this experimental setup depicted in the figure below involves moving a bar magnet in a direction of the coil that has a galvanometer as the end. State the energy change in which take place the magnet is moved inside the coil. So when the magnet is moving, that is mechanical energy, and it is getting converted to electrical energy, okay, where the galvanometer is moving. Define the phenomena that has been demonstrated in the experiment. Okay, so that is electromagnetic induction, and they are asking you to define, not to state that. So this is a little, yeah.
So I have written instead of the change in magnetic flux, I wrote electromagnetic flux, so give the entire thing wrong.
Yeah, so electromagnetic flux is not a correct word. Okay. So magnetic flux. So here there is a magnet. So the magnetic flux associated with the coil changes. So there is EMF induced in the coil. That is electromagnetic induction. But there are two parts to it. First part you should have got mechanical energy to electrical energy.
Yes, I got the second one.
Okay. Now there is another graph-based question of calorimetry. The diagram shows phase change versus time graph on heating at a constant rate. Why is the slope CD less than the slope AB? So why is the slope? Now, when you're talking about slope, they are talking about change in Y upon, so this is temperature upon time. Okay. So basically you have, this is heat energy. Okay. And you have this thing is Q is equal to MC delta T. So when I take the delta T on the other side, and mass is also constant because it's the same substance that is changing. So that is proportional to C. So over here, it says that if slope of CD is less, that means specific heat capacity will be more. It is taking longer time, right? What was the answer expected in this?
So latent heat and the change of state. How?
Over here, what
No,
is
I
the
think we
vol-
had to write for the first one we had to write that it takes more time and that's why the
Yeah.
slope is lesser.
Okay, so it takes a longer time. Just that. Okay, they have
Yes.
nothing to do with specific heat capacity.
No.
No, I mean I didn't write it, but I still got the mark. So I think it was they were looking for the time thing.
Okay,
Sir,
so
I
why?
didn't. So I didn't get the mark.
Understood. Fine, because I
Uh,
don't. Yeah,
So the second part, so so has given it wrong, and he has written BP as T2 and MP as T1.
yeah.
Yeah.
This is melting, na, and this is boiling.
Yes, sir.
So this is very clear that first it will melt and then it will boil. Now over here, which one point of a difference between the following: chemical change and nuclear change? Okay, this is a very theory question. And chemical change, like there is a transfer or share of electrons. Nuclear change is when there is emission of alpha, beta, gamma radiations. Okay, beneficial and harmful effect of nuclear radiations. So beneficial, you can say any of the medicinal use, and harmful effect is they cause damage to the human tissue, they cause cancer. These things can be mentioned. Okay, question number 4. A spear fisherman uses a strange trick to catch fish. He aims at a fish slightly below the observed position of the fish. Why does the spearman aims at a fish slightly below the position? Okay, because of the refraction of light. So the person in the rarer medium, when looks at anything which is in a denser medium, it appears to be raised. Okay, so the perceived position of the fisherman would be somewhat higher or lower than the actual position. So this is a real and this is apparent, or the perceived position. Okay, if the fish tries to see the fisherman, where will he see him? So if the observer is in a denser medium and the object is in a rarer medium, then the object appears taller. Okay, so the object will appear taller. Fine. Then what is the actual position of the fish when the fisherman located at a depth of 5 meters below? So this is 1.4 is real depth upon
7 meters.
apparent depth. Yeah. So this will be how much? 7 meters. Yeah. 1.4 into 5, that will be 7 meters. Okay. So the easy question. Okay. Now here, position of gravity for a parallelogram is meeting points of the diagram. So whenever you draw this, you have to draw. They are asking you to draw, and you have to label G over there. Okay, so you must have seen a tightrope worker showing the trick of an open field on a street. What is the basic physics behind it? So if this is the center of mass acting on the rope, then the person will be able to balance. Okay, because if the anti-clockwise and the clockwise torque is equal, then the person will be able to balance. Okay, that means the weight of this person should fall exactly on the rope, then the person will be able to balance. Okay, fine. So this is the second one. This I hope you all should have got it. This is 30 into 4, that is clockwise, and 50 into 5, that is also clockwise. 20 into 1, that is anti-clockwise, and 80 into 3, that is anti-clockwise. So this is 0 because it's directly acting on the this thing. So what was the resultant? Do you remember? 30 into 4 plus 50 into 5. So that will be 370. And here you have 20 into 1 plus 80 into 3. So 20 plus 260. So that will be 110 Newton meter clockwise. Okay. Fine. Now moving ahead, a figure given below shows an object AB, and this is an image. So obviously it's a virtual magnified image. So name the lens, convex lens. Show how it is forming the image, A dash, B dash. So when you join this, that is the position you are going to get a lens. Okay, so remember this is dotted. Now when you take this again from here, you take a line, proceed, that is the focus. Okay, clearly mark on the diagram the focus and the position of the eye by marking X. So this is X, and okay, no, they want X, position the focus. I should be X. Fine. Question 7. Yeah.
I didn't understand the second part on which they said to mark the focus as X.
Yeah. So over here now, see, if nothing is given to you, like how do you make a diagram in the first place? So this is a lens, this is focus, and this is also focus. So you place an object, okay? So first you know this is focus and this goes through the focus. You know the second is goes through the lens. So when you bring that back, when you bring this back like SA, then this is where the image is formed. Now what they have given you, they have given you image, they have given you object, and they are asking you to find the lens and the focus. So what you will do is you will join the tip of the arrows this way. So where it intersects, that is the position of the lens. Now see this ray, you took it straight. So you take this straight. Now again you have one point and the other point, the tip of the arrow. So that also you will join. And this you proceed. So this will be focus and your eye will be over here.
Okay, thank you, sir.
Yeah.
So,
Yes.
I have a doubt in question number 5.
Okay, wait now.
Yes, sir.
Name and define the vibration executed by a pendulum in air. So that will be damped vibration. In the figure shown, test tube A and B, each of height 20 centimeters, are filled with water up to 14 and 18. So this is 6 and this is 2. If the vibrating tuning fork is placed over this mouth of the test tube B, a loud sound is heard. So that means there is resonance happening at 2. Will it produce a loud sound when placed over A? Yes, because the air column closed at one end, there are odd multiples. So if this is happening at 2 centimeter, this will happen at 6 centimeter and 10 centimeter. So answer is yes, it will. Again, this is similar to the textbook question. The good modification and have asked that. Okay. Now here, this is a very good question. Again, this is north and south. So the magnetic field is in this direction. I take the alpha particle as the direction of current. And if I use my Fleming's left-hand rule, that means alpha particle goes inside. Okay, alpha particle will go inside the page. Then obviously beta particle will come out of the page. And gamma is going to go straight because it has no charge. So into the page is alpha, out of the page is beta, and no deflection is gamma. Okay, any question on this? This is use of Fleming's left-hand rule. Okay. Then what we have over here, a sound wave traveling in water has a wavelength of 0.4 and speed is this. So what is the frequency? Velocity is frequency into wavelength. So 1400 is equal to frequency into 0.4. So this is 4. 4 3 are 12, 25. 3500 hertz is the frequency. Is the wave audible in air? Okay, so now for a particular medium, when it goes from particular wave, when it goes from one medium to another medium, frequency does not change. Frequency is a characteristic. So in air also, the frequency will be 3500 hertz and it is within the audible range. So is the wave audible? Answer is yes. Okay, justify with your reason. You have to first say that frequency does not change. Second, audible range is 20 hertz to 20,000 hertz and it lies in that audible range. Okay, question number 8. A circuit is made with a combination of two cells of a resistor, cells a resistor 1.8 ohm and an unknown resistor X and an ammeter. All are connected in series. Okay, there are cells has 3 volt and 0.1 ohm each. So let me just draw a diagram. And then you have one resistor and another resistor. So this is 1.8 ohm. This is X. Now there are two cells of 3 volt each. So that will be 6 volt. And their internal resistance also will get added because the cell are in series. So that is 0.2 ohm. So draw the diagram. If the ammeter reads 1 ampere. So E is equal to I, small r plus big R. So this is 6 volt, this is 1 ampere, this is 0.2 plus R. So therefore, this will be equal to what? 5.8. Okay, now 5.8 is equal to 1.8 plus X. So X will be equal to 4 ohm. What is the potential difference across X? So here 1 ampere is flowing. So the same amount of current will flow through X also. So the potential difference is equal to V equal to IR 1 into 4. So that will be 4 volt. Okay, any questions?
So
Yeah.
So I didn't multiply like the 0.1 and 3 by 2, like only
Same.
2, so my entire
Yeah,
thing got
so
blocked.
same.
Okay. So here they have said 2 cells, and this, so that was something you need to pay attention now. Is it possible for protonium to emit alpha particle? No. Now, I think in chemistry also you study the names of isotopes of hydrogen. So you should know now. Also, one logical question is that alpha particle has 2 protons and 2 neutrons. So protonium do not have this. So therefore it cannot emit. Like suppose you in your pocket, if you have 10 rupees, you cannot give anyone 1,000 rupees because you don't have that. So similarly, a hydrogen atom cannot give 2 protons and 2 neutrons. It does not have it. So therefore the answer is no. A nucleus of an atom X has a neutron number 30 and atomic number 18. So therefore atomic number means number of protons are 18, and 30 plus 18 will be 48. So X will be 48 and 18. 4 protons are lost from atom X. What will be the symbol of the daughter nuclei? So 4, so that will be 44X and 14. So that will be Y. Okay. Now in this diagram below, observe the diagram and answer the question. Identify the terminal P. Now, if you look at the diagram, is not so clear. Let me just check. So R is jumping here, and from R, so this is connected to R. Okay. Q is connected to the innermost, and from the innermost, so this is Q. So this will be P. Okay. So you know that this is Earth. Which one is this? Another hint, this is live also because you can see that fuse is connected. And this will be neutral. Okay. Then what you have, name and state the function of what is shown as A. So A is a switch, B is a fuse, right? Why is a ring system of a house cost effective? There are 2-3 examples here to use same kind of a switch. Okay, then you don't need thicker wires. So all those things are the reason why cost is reduced. In spite of a fault in the ring system of wiring, all electrical appliances are connected to it were not affected as a whole because they are connected parallel to each. Okay, so because they are connected parallel, one stops working, the other will continue to work. Okay, then you have question number 9. 2 metallic blocks P and Q have masses in the ratio 2:1. So this is P, this is Q. Mass is 2m and this is m. Supplied with the same amount of heat, Q is same. If the temperature rises by the same degree, compare the specific heat. So C1 and C2 we have to compare. Now they get the same amount of heat. So Q is equal to Q. So that means M C1 delta T is M C2 delta T. Now rise in temperature is also same. So therefore C1 upon C2 is M upon 2M, which is 1 by 2. So C1 is to C2 is 1 is to 2. So the answer to this is 1 is to 2. Why? Okay, this is what I had mentioned, which is not in the portion. So steam has severe burns than boiling water. Now steam is in gaseous state. When steam touches your hand, it takes the latent heat amount of heat from your hand, and then steam will turn into boiling water, which is at 100 degrees Celsius. So the gas will give that much heat, the gas will give that much heat to your hand, and then it will turn into boiling water. So your hand will cause more burns compared to boiling water. Okay. A similar question that should have been asked is like, when you hold a ice in your hand will become numb, okay, faster compared to holding hand in a 0 degree water. Okay. If you have ever taken part in that, ice challenge, standing on a block of ice. So who stands for the longer time? Okay. Next, what you have is a lead cannonball of mass 1 kilogram penetrates into a solid object and melts. The initial temperature of the cannonball is 27 degrees and the melting point is 237. Okay, so therefore delta T is equal to 300 and this is the mass. Okay, so latent heat is also given. Calculate the heat required to raise the temperature of the cannonball. So Q is equal to mc delta T. So mass is equal to 1. Specific heat capacity is 125 and this is 300. So that will be 37500 joules. Calculate the heat required to melt. Melt is always m into L. So this is 1 into 2.5 into 10 to the power 4. So 2.5 into 10 to the power 4 joules is also this. Okay. Now, if 50% of the kinetic energy of the ball was used to heat it, then calculate the initial speed of the cannonball. So now what we have to do is, this is how many zeros? There are 4. So 1, 2, 3, 4. But this will not be there. Okay. And what do you have? 37500. 005. Okay, so this will be 625. Now 50% of kinetic energy. So this is equal to half m v squared is equal to 62500. Okay, so this is 2. 52s are. Now these two 2's I'll take on the other side. Mass is equal to 1. So v square is 625 into 100 into 2 into 2. So v will be equal to 625 square root is 25, 100 is 10, and this is 2. So this will be 500 meter per second is the speed. Okay, any questions, anyone? Okay, then what do you have? The length of a copper wire, A and B, are in the ratio 1:1. So if you talk about A, B, length is L and L. Area of cross section, wire A is thicker than B. So I can take A and small a just for that. Which wire is expected to offer more specific resistance? So since both are copper, both have the same value of specific resistance. Which wire will conduct better, which has less resistance? So A will conduct better. If A has an initial resistance of 2 ohms, how does it change if the its resistance when it is stretched uniformly? Okay, so I'm just going to erase this. We are talking about only A. A has a resistance of 2 ohms and now it is stretched uniformly and its initial area is decreased to 1/4. Okay, maintaining a constant volume. So if the cross section area becomes 1/4, then the length will become 4 times. So that means the new resistance will be 16 times the original resistance. So 16 into 2, that is 32 ohms. Remember one thing, I have told you that if a wire is stretched 2 times, the resistance becomes 2 squared. So that will become 4 times. If the wire is stretched 3 times, so this will become 9 times. Now, why does that happen? Because if you have a wire whose length is L and area of cross section is A, then when you make its length double, the area of cross section becomes half. And you have this formula that R is equal to rho L upon A. So L is 2L, A is A by 2. So this is 4 times rho L by A. So it becomes 4 times. That's why. And also when they're talking about, that's the logic, the volume remains same in both the places. And volume of a cylinder is pi r square h. So pi r square is area of cross section. H is the length. Fine. So that was the end of the paper.